Hello all, my name is Shannon O'Shell, and today we are going to be talking about comparative forensic science. Comparative forensic science focuses on analyzing patterns and impressions to determine whether evidence came from the same source. This includes fingerprints, footwear impressions, tire tracks, and tool marks. These analyses require not just observation, but critical thinking and interpretation, because no two impressions are ever perfectly identical. Objectivity refers to observations that can be measured and verified. In forensic science, this includes things like ridge counts and fingerprints, measurements of tool marks or pattern dimensions. Objective methods help ensure consistency and reduce bias because they rely on data rather than opinion. Subjectivity involves the examiner's interpretation of the evidence. Even with objective data, a scientist must decide whether similarities are significant. This relies on training and experience. Subjectivity is necessary, but also introduces the possibility of bias, which is why safeguards are important. Forensic scientists balance objectivity and subjectivity through structured processes like ACE-V, which stands for analysis, comparison, evaluation, and verification. This helps to ensure the conclusions are supported by data while still allowing expert interpretation. Peer review and verification help reduce bias. Comparative forensic experts use three types of logic. Deductive logic applies general principles to specific cases. Inductive logic builds conclusions based on observed patterns. Abductive logic identifies the most likely explanation for all of the evidence. Together, these forms of reasoning support scientific conclusions. Form refers to the overall structure of an object, while pattern refers to how features are arranged. These often represent class characteristics, meaning they can group objects together but do not identify a single source. For example, a shoe tread design can identify the brand but not the exact shoe. Feature persistence refers to how well characteristics remain stable over time. As objects are used, they develop wear and damage that creates unique features. These random characteristics are extremely important because they help distinguish one object from another. Natural patterns occur without human design and are often inherently unique. Fingerprints are a classic example. These patterns are highly valuable because they naturally contain individualizing features. Unnatural patterns are created through manufacturing and are initially identical across many items. However, as they are used, they develop unique wear patterns. This combination of class and individual characteristics make them useful for comparison. Expert judgment is used to evaluate whether two patterns came from the same source. Scientists consider both the quantity and the quality of features. Rather than claiming absolute certainty, they assess whether the evidence supports a common origin. First-level detail includes general characteristics like overall shape, size, and pattern type. This level is useful for excluding sources but is not enough for individual identification. Second-level detail includes specific features such as ridge endings and bifurcations. They are much more individualizing and are commonly used in fingerprint comparisons. Third-level detail includes very fine characteristics that require magnification to observe. These features provide additional support for identification but depend heavily on image quality. Both quantity and quality of features matter, but quality is often more important. A few clear, well-defined features can provide stronger evidence than many unclear ones. Comparative forensic science combines objective data with expert interpretation. Understanding patterns, persistence, and levels of detail allow scientists to make informed conclusions. These decisions rely on both scientific reasoning and professional judgment.